All right, we're going to start this video with the non-calculator part of the review, and we'll see how far I get. So I know this says quiz. It's not the quiz, it's the review. But just like all of the reviews, it's pretty similar to the layout of the quiz, so you'll kind of know what to expect. All right, for each quadratic function, find all the specified information and then graph the parabola. So standard form, which is vertex form, equation. Remember, for this, you have two options. You can complete the square or you can use the vertex formula. I prefer to use the vertex formula, which is find the vertex first using opposite of b over 2a, so positive 8 over 2 times 1. And so the x-coordinate of the vertex is 4. And then to find the y-coordinate, you plug in f of 4. So 4 squared is 16, minus 8 times 4 is minus 32. So that's negative 16. So I'm going to be off the graph a little bit. It's okay. And then if the vertex is at, I'm going to write down the vertex first. So if the vertex is at 4, negative 16, then I can write the vertex form equation. So it's going to be f of x equals, there's nothing in front of the x squared, so I don't have to put anything in front of my parentheses. And it's going to be x minus 4 squared minus 16. So remember, you're just putting in the vertex x minus h squared minus 16. And if there's a number in front of parentheses, it matches whatever was in front of the x squared here. Axis of symmetry is the vertical line that goes through the vertex, so x equals 4. X-intercepts are what we get when we set the equation equal to 0. And remember, this is either factoring, square root method, or quadratic formula. In this case, I can factor an x out. So I get x-intercepts of 0 and 8. Box in all my answers here, sorry. And then the y-intercept, now this we had in our textbook homework. This would be when you plug in 0, because any y-intercept is like 0y. So when you plug in 0 into the function, you get 0 minus 0. So that's 0. So the y-intercept is y equals 0. You can write these as ordered pairs, or you can write them just with their values. That's fine. So if I want to graph this, I'm going to start by plotting the zeros just because I have them conveniently here. I don't think I'm going to change the scale. So for negative 16, I'm just going to say it's like down here somewhere. And then I'm just going to sketch this in. So because we're not doing transformations, if you just plot the y-intercept, the vertex, the x-intercepts, and if there's a symmetric point to hop across, then you can, then that's fine with me. If you want to draw in the axis of symmetry, again, you can, not required. Okay, so let's take a look at number 2. So standard form equation, again, I'm going to find the vertex first. So basically I'm finding the vertex first, and then I'm writing the equation second. All right, so the vertex formula is x equals opposite of b, negative 2, over 2 times a, 2 times negative 1. So negative 2 divided by negative 2 is positive 1. And then the y-coordinate comes from plugging that value into f. Negative 1 squared is still negative 1 because the negative's on the outside, plus 2 times 1 plus 5. So 1 plus 5 is 6. So there's a vertex at 1, 6. And then the standard form equation now, because there's a negative in front of the x squared, I'm going to write f of x equals negative parentheses x minus 1 squared plus 6. So that's your standard form or vertex form equation. So we plot a point at 1, 6, and I could draw the axis of symmetry in right now if I want. It's at x equals 1. You can graph as you go if you like to. X-intercepts, we get those from when we set the equation equal to 0. Now, this does not factor, right? There are no numbers that multiply to 5, which are only 5 and 1, that are going to add or subtract to 2. So I need to use the quadratic formula on this. So how am I going to plot those x-intercepts? I'm probably not. I'm going to rely on the y-intercept, but I still want to find them. So x-intercepts are going to be negative 2 plus or minus square root of b squared is 4 minus 4 times a times c. Remember, it's a, b, c, all over 2 times, oops, I don't want to actually write a, 2 times a, which is negative 1. And then remember, we're not using a calculator on this, so do the math correctly here. So just cover up the 4 that's in front. Negative 4 times negative 1 is 4. 4 times 5 is 20. So this is the square root of 4 plus 20 over negative 2. And because that's the square root of 24, we want to simplify that. That's negative 2 plus or minus 2 radical 6 all over negative 2. Now, if these three numbers on the outside are all divisible by a common factor, in this case I can divide them all by either 2 or negative 2, then you need to do that. If only 2 of them are divisible, then you can't break it up. So I'm going to divide everything by negative 2, and that's going to give me positive 1. Plus or minus 2 divided by negative 2 is still plus or minus 1, radical 6. And then 2 divided by negative 2 is 1, so I don't really need the 1 anymore. All right, so that's my final answer for the x-intercepts. And again, I'm not really going to plot those. They're decimals, so I'm not going to worry about that. The y-intercept is what I get when I plug in 0. So 0 plus 0 plus 5. So we get 5. So I can plot 5, and then I can hop that across the axis of symmetry. You need at least 3 points for a parabola, and we'll just stop there. So if the x-intercepts are nice, plot them. If they're not nice, that's okay. All right, what about this one? Find the vertex first and then find the standard form equation. So you can find the vertex. Now this one does factor. Maybe you are looking at this and like, oh, it factors into that. That's vertex form right there. But if you want to keep things consistent, the x-coordinate is negative 6 over 2 times a, so negative 3. The y-coordinate is plugging negative 3 into f. So square it, you get 9. 6 times negative 3 is negative 18, plus 9. Negative 9 plus 9 is 0. So there's a vertex at negative 3, 0. So vertex form would be f of x equals, there's nothing in front of x squared, x plus 3 squared, plus 0 technically, but you don't have to write that. And I got that just from factoring it too. So this one, the only time you can factor to get vertex form or standard form is when it's one of these perfect square trinomials. It factors into the same thing times itself. So let's plot as we go here. There's that. Axis of symmetry, x equals negative 3. If you graph as you go, you can also answer some of these questions. Like x-intercepts, I can see the only x-intercept is the vertex. It's x equals negative 3. But again, you can factor this and say if x plus 3 times x plus 3 is equal to 0, then yeah, x equals negative 3. For the y-intercept, if you plug in 0, you get 0 plus 0 plus 9. So y equals 9 is the y-intercept. So I can plot that. And then here's how you can use the axis of symmetry. This is 3 units to the right of the axis of symmetry. So reflect a point that's 3 units to the left of the axis of symmetry, and that fits our value as well. You are allowed to plot more points. This is the x squared graph. So you could plot 2 other points in there, but 3 is the minimum for this. All right. Use the table to determine whether this function represents a linear or quadratic function. So the first thing that we should be doing when we see a table and we're trying to decide is find the first average rate of change, and then also find the second. And be careful because these x's are going up by 2, so not going up by 1. So you do have to pay attention to them. So let's draw in our little tables here. Okay, so 44, so nothing here. 44 minus 8 over 4 minus 2. So 44 minus 8 is 36. 36 divided by 2 is 18. 104 minus 44 over 6 minus 4. So 104 minus 4 is 100, minus 40 is 60. 60 divided by 2 is 30. 188 minus 104 over 8 minus 6. So this gives me 84 divided by 2. So that's 42. All right. And let's see. 296 minus 188 over 10 minus 8. No shame in doing a little math off to the side here, right? So borrow from there, make that 16. 16 minus 8 is 8. 8 minus 8 is 0. 2 minus 1 is 1. 108 divided by 2 is going to be 54. Right? Yeah, 54. Okay, so is this linear or quadratic? Definitely not linear because the first average rate of change is not constant. Let's find the second average rate of change. Because remember, we're going to learn about more than just quadratics. So just because the linear isn't constant, the first average rate of change isn't constant, doesn't mean it's automatically quadratic. So nothing for the first two blanks. And then you're using the x coordinates and the average rate of change coordinates. So 30 minus 18 over 6 minus 4. So that's a difference of 12 over 2, which is 6. And then here, 42 minus 30 over 8 minus 6. That's again 12 over 2. 54 minus 42 over 10 minus 8. That's 12 over 2. So it's not just because the first average rate of change is not constant. It's because the second average rate of change is constant. Basically, these slopes are always going up by 6 per unit. That's how we know it's quadratic. If the third average rate of change was constant, it'd be cubic. That's what we'll get into later in this chapter. Okay, so linear or quadratic, how can you tell using the first and second differences? So, instead of differences, it's better to say first average rate of change and change in average rate of change or second average rate of change. So I'm just going to say this is quadratic because the second average rate of change is constant. Constant. There we go. Are the average rates of change increasing, decreasing, or constant? So this doesn't say the change in or the second average rate of change. It means the first average rate of change. Increasing, decreasing, constant. So just look at the numbers. They're going from 18 to 30 to 42. Those are definitely going up, right? So increasing. So the AROC, maybe I'm going to put this in here to emphasize. AROC is increasing. What type of concavity does f of x have? Because AROC is increasing, f of x is concave up. Remember, we learned that in chapter 1, and it's going to keep coming back to us over and over and over. Okay, I'm going to stop this here for the non-calculator section, and then there will be a second video for the calculator part.